CIET NCERT presents Contemporary India. The audio textbook in Geography for Class 10, Part 2. Chapter 5. Minerals and Energy Resources. This chapter contains 15 pages. Page 50. Chapter 5. Minerals and Energy Resources. Friends, before we begin with this chapter, Minerals and Energy Resources, we have a conversation between a boy and his father who live in a remote village. Haban comes to Guwahati with his father from a remote village. He sees people getting into strange house-like objects which move along the road. He also sees a kitchen dragging a number of houses along with it. He is amazed and asked his father, "Why don't our houses move like the one we saw in Guwahati, Ba?" Ba replies, "These are not houses, they are buses and trains. Unlike our houses, these are not made of bricks and stones. Metal like iron and aluminium are used in making these. They do not move on their own. They are driven by an engine which needs energy to work." Now from the text. We use different things in our daily life made from metal. Can you list a number of items used in your house made of metals? Where do these metals come from? You have studied that the Earth's crust is made up of different minerals embedded in the rocks. Various metals are extracted from these minerals after proper refinement. Minerals are an indispensable part of our lives. Almost everything we use, from a tiny pin to a towering building or a big ship, all are made from these minerals. The railway lines and the tarmac paving of the roads. Our implements and machinery too are made from minerals. Cars, buses, trains, aeroplanes are manufactured from these minerals and run on power resources derived from the earth. Even the food that we eat contains mineral. In all stages of development, human beings have used minerals for their livelihood, decoration, festivities, religious and ceremonial rites. We have a very interesting information in this box. A bright smile from toothpaste and minerals. Toothpaste cleans our teeth. Abrasive minerals like silica, limestone, aluminium oxide, and various phosphate minerals do the cleaning. Fluoride, which is used to reduce cavities, come from a mineral fluorite. Most toothpastes are made white with titanium oxide, which comes from minerals called rutile, ilmenite, and anatase. The sparkle in some toothpastes comes from mica. The toothbrush and tube containing the paste are made of plastics from petroleum. Find out where these minerals are found. Dig a little deeper and find out how many minerals are used to make a light bulb. All living things need minerals. Life processes cannot occur without minerals. Although our mineral intake represents only about 0.3% to our total intake of nutrients, they are so potent and so important that without them we would not be able to utilize the other 99.7% of foodstuffs. Dig a little deeper and collect nutritional facts printed on food labels. Page 51. What is a mineral? What is a mineral? Geologists define mineral as a homogeneous, naturally occurring substance with a definable internal structure. Minerals are found in varied forms in nature, ranging from the hardest diamond to the softest talc. Why are they so varied? You have already learned about rocks. Rocks are combinations of homogeneous substances called minerals. Some rocks, for instance limestone, consist of a single mineral only, but majority of rock consist of several minerals in varying proportions. Although over 2,000 minerals have been identified, only a few are abundantly found in most of the rocks. A particular mineral that will be formed from a certain combination of elements depend upon the physical and chemical conditions under which the material forms. This, in turn, results in a wide range of colors, hardness, crystal forms, luster, and density that a particular mineral possesses. Geologists use these properties to classify the minerals. Study of minerals by geographers and geologists. Geographers study minerals as a part of the Earth's crust for a better understanding of landforms. The distribution of mineral resources and associated economic activities are the interest of geographers. A geologist, however, is interested in the formation of minerals, their age, and physical and chemical composition. Classification of minerals. However, for general and commercial purposes, minerals can be classified as follows. Figure 5.1. Classification of minerals. Minerals can be classified in three broad categories: metallic, non-metallic, and energy minerals. Metallic minerals are classified under three categories: ferrous, that is containing iron. Example, iron ore, manganese, nickel, cobalt, etc. The second category of metallic minerals is non-ferrous. Example, copper, lead, tin, bauxite, etc. And the third category is the precious. Example, gold, silver, platinum, etc. The non-metallic minerals are found in the Earth's crust, and the examples are as follows: mica, salt, potash, sulfur, granite, limestone, marble, sandstone, etc. Energy minerals contain coal, petroleum, and natural gas. Mode of occurrence of minerals. Where are these minerals found? Minerals are usually found in ores. The term ore is used to describe an accumulation of any mineral mixed with other elements. The mineral content of the ore must be in sufficient concentration to make its extraction commercially viable. The type of formation or structure in which they are found determines the relative ease with which mineral ores may be mined. This also determines the cost of extraction. It is, therefore, important for us to understand the main types of formations in which minerals occur. Minerals generally occur in these forms. First, in igneous and metamorphic rocks, minerals may occur in the cracks, crevices, faults, or joints. The smaller occurrences are called veins, and the larger are called lodes. In most cases, they are formed when minerals in liquid or molten and gaseous forms are forced upward through cavities towards the Earth's surface. They cool and solidify as they rise. Major metallic minerals like tin, copper, zinc, and lead, etc., are obtained from veins and lodes. Second, the sedimentary rocks, a number of minerals occur in beds or layers. They've been formed as a result of deposition, accumulation, and concentration in horizontal strata. Coal and some forms of iron ore have been concentrated as a result of long periods under great heat and pressure. Another group of sedimentary minerals include gypsum, potash salt, and sodium salt. These are formed as a result of evaporation, especially in arid regions. Third, another mode of formation involves the decomposition of surface rocks and the removal of soluble constituents, leaving a residual mass of weathered material containing ores. bauxite is formed this way. Page 52. Fourth, certain minerals may occur as alluvial deposits in sands of valley floors and the base of hills. These deposits are called placer deposits and generally contain minerals which are not corroded by water. Gold, silver, tin and platinum are most important among such minerals. Fifth, the ocean waters contain vast quantities of minerals, but most of these are too widely diffused to be of economic significance. However, common salt, magnesium and bromine are largely derived from ocean waters. The ocean beds too are rich in manganese nodules. India is fortunate to have fairly rich and varied mineral resources. However, these are unevenly distributed. Broadly speaking, peninsular rocks contain most of the reserves of coal, metallic minerals, mica, and many other non-metallic minerals. Sedimentary rocks on the western and eastern flanks of the peninsula in Gujarat and Assam have most of the petroleum deposits. Rajasthan, with the rock systems of peninsula, has reserves of many non-ferrous minerals. The vast alluvial plains of North India are almost devoid of economic minerals. These variations exist largely because of the differences in the geological structure, processes and time involved in the formation of minerals. Let us now study the distribution of a few major minerals in India. Always remember that the concentration of mineral in the ore, the ease of extraction, and closeness to the market play an important role in affecting the economic viability of a reserve. Thus, to meet the demand, a choice has to be made between a number of possible options. When this is done, a mineral deposit or reserve turns into a mine. A very interesting fact from the box. Rat hole mining. Do you know that most of the minerals in India are nationalized and their extraction is possible only after obtaining due permission from the government? But in most of the tribal areas of northeast India, minerals are owned by individuals or communities. In Meghalaya, there are large deposits of coal, iron ore, limestone and dolomite, etc. Coal mining in Jowai and Cherrapunji is done by family members in the form of a long narrow tunnel known as rat hole mining. Dig a little deeper. What is the difference between an open pit mine, a quarry, and an underground mine with shafts? Ferrous minerals. Ferrous minerals account for about 3/4 of the total value of the production of metallic minerals. They provide a strong base for the development of metallurgical industries. India exports substantial quantities of ferrous minerals after meeting her internal demands. Iron ore. Iron ore is the basic mineral and the backbone of industrial development. India is endowed with fairly abundant resources of iron ore. India is rich in good quality iron ores. Magnetite is the finest iron ore with a very high content of iron up to 70%. It has excellent magnetic qualities, especially valuable in the electrical industry. Hematite. Hematite ore is the most important industrial iron ore in terms of quantity used, but has a slightly lower iron content than magnetite, that is 50 to 60%. Figure 5.2. Production of iron ore showing state-wise share in percent 2004-2005. The pie diagram shows the distribution of iron ore in the different states. Karnataka holds the share of 26% as the highest in the country. Odisha contributes 25% of iron ore production in the country, whereas Chhattisgarh contributes 19%, Goa as 17%, Jharkhand 12%, and all the rest of the states contribute just 1%. Figure 5.3 shows an iron ore mine. Page 53. From the box. Do you know? Kudre is Kannada means horse. The highest peak in the western Ghats of Karnataka resembles the face of a horse. The Bailadila hills look like the hump of an ox, and hence its name. The major iron ore belts in India are: first, Odisha Jharkhand belt. The Odisha high-grade hematite ore is found in Badam Pahar mines in the Mayurbhanj and Kendujhar districts. In the adjoining Singhbhum district of Jharkhand, hematite iron ore is mined in Goa and Noamundi. Second, Durg, Bastar, Chandrapur belt lies in the Chhattisgarh and Maharashtra. Very high-grade hematites are found in the famous Bailadila range of hills in the Bastar district of Chhattisgarh. The range of hills comprise of 14 deposits of super high-grade hematite iron ore. It has the best physical properties needed for steel making. Iron ore from these mines is exported to Japan and South Korea via Visakhapatnam port. Third, Bellary, Chitradurg, Chikmagalur, Tumkur belt in Karnataka has large reserves of iron ore. The Kudermukh mines located in the western Ghats of Karnataka are a 100% export unit. Kudermukh deposits are known to be one of the largest in the world. The ore is transported as slurry through a pipeline to a port near Mangalore. Fourth, Maharashtra-Goa belt includes the state of Goa and Ratnagiri districts of Maharashtra. Though the ores are not of very high quality, yet they are efficiently exploited. Iron ore is exported through Marmagao port. Manganese. Manganese is mainly used in manufacturing of steel and ferromanganese alloy. Nearly 10 kg of manganese is required to manufacture 1 ton of steel. It is also used in manufacturing bleaching powder, insecticides, and paints. Odisha is the largest producer of manganese ores in India. It accounted for 1/3 of the country's total production in 2000-2001. Figure 5.4. A pie chart is given which shows the production of manganese, state-wise share in percent in the year 2003-2004. It shows that Odisha has its maximum contribution of 33%, followed by Madhya Pradesh as 22% and Karnataka 15%. The rest of the other states contributes the rest of the 30%. Dig a little deeper. Superimpose the maps showing distribution of iron ore, manganese, coal, and iron and steel industry. Do you see any correlation? Why? Page 54. The given map of India shows the iron ore mines, iron ore fields, iron ore exporting ports, manganese mines, bauxite mines, and mica mines. Most mineral occurrences are in the pockets of Jharkhand, Odisha, Chhattisgarh, Maharashtra, Goa, Karnataka, and Rajasthan. The mica mines are found in the states of Rajasthan, Bihar, Jharkhand, and Karnataka. The names are as follows: Ajmer and Biyawar in Rajasthan, Gaya in Bihar, Hazaribagh in Jharkhand, and Nellore in Andhra Pradesh. We have bauxite mines in various parts of the country, out of which Katni and Amarkantak are the most famous in Madhya Pradesh. Manganese is also found in various parts of the country. Shimoga is a very famous mine in Karnataka, Sundargarh in Odisha, and Kendujhar in Odisha. Whereas we have Nagpur and Bhandara from Maharashtra. We also have a few ports famous for exporting iron ore, like Paradeep in Odisha, Vishakhapatnam in Andhra Pradesh, Mangalore in Karnataka. Some of the famous iron ore mines are Mayurbhanj, Kendujhar in Odisha, Goa in Jharkhand, Durg and Beladila in Chhattisgarh, Chandrapur in Maharashtra, Ratnagiri in Maharashtra on the west coast, Kudermukh in Andhra Pradesh, Chikmagalur, Tumkur, Chitradurga also in Andhra Pradesh. Non-ferrous minerals. India's reserves and production of non-ferrous minerals is not very satisfactory. However, these minerals, which include copper, bauxite, lead, zinc, and gold, play a vital role in a number of metallurgical, engineering, and electrical industries. Let us study the distribution of copper and bauxite. Page 55. Copper. India is critically deficient in the reserve and production of copper. Being malleable, ductile, and a good conductor, copper is mainly used in electrical cables, electronics, and chemical industries. The Balaghat mines of Madhya Pradesh produce 52% of India's copper. The Singhbhum district of Jharkhand is also a leading producer of copper. The Khetri mines in Rajasthan are also famous. Figure 5.5, a picture showing copper mines at Malanjkhand. Figure 5.6, there's a pie diagram given which shows the production of copper state-wise share in percent in the year 2003-2004, where Madhya Pradesh holds the maximum production of 58% and Rajasthan holds only 42%. Bauxite. Though several ores contain aluminum, it is from bauxite, a clay-like substance, that alumina and later aluminum is obtained. Bauxite deposits are formed by the decomposition of a wide variety of rocks rich in aluminum silicates. Aluminum is an important metal because it combines the strength of metals such as iron with extreme lightness and also with good conductivity and great malleability. Figure 5.7, the pie chart shows the production of bauxite. Again, it is shown state-wise with its share in percent and for the year 2003-2004. Odisha contributes 45%, followed by Gujarat with 17%, Jharkhand with 14%, Maharashtra as 11%, and others 13%. Figure 5.8, there's a picture which shows a bauxite mine. India's bauxite deposits are mainly found in the Amarkantak Plateau, Maikal Hills, and the plateau region of Bilaspur, that is in Katni. Odisha is the largest bauxite producing state in India, with 45% of country's total production in 2000-2001. Panchpatmali deposits at Koraput district are the most important bauxite deposits in the state. Dig a little deeper. Locate the mines of bauxite on the physical map of India. Page 56. There is a very interesting fact given here in the box. After the discovery of aluminum, Emperor Napoleon III wore buttons and hooks on his clothes made of aluminum and served food to his more illustrious guests in aluminum utensils, and the less honorable ones were served in gold and silver utensils. 30 years after this incident, aluminum bowls were most common with the beggars in Paris. Non-metallic minerals. Mica. Mica is a mineral made up of a series of plates or leaves. It splits easily into thin sheets. These sheets can be so thin that 1,000 can be layered into a mica sheet of a few centimeters high. Mica can be clear, black, green, red-yellow, or brown. Due to its excellent dielectric strength, low power loss factor, insulating properties, and resistance to high voltage, mica is one of the most indispensable minerals used in electric and electronic industries. Mica deposits are found in the northern edge of the Chota Nagpur Plateau. Koderma Gaya, Hazaribagh belt of Jharkhand is the leading producer. In Rajasthan, the major mica producing area is around Ajmer. Nellore mica belt of Andhra Pradesh is also an important producer in the country. Rock minerals. Limestone is found in association with rocks composed of calcium carbonate or calcium and magnesium carbonates. It is found in sedimentary rocks of most geological formations. Limestone is the basic raw material for the cement industry and essential for smelting iron ore in the blast furnace. Dig a little deeper. Study the maps to explain why Chota Nagpur is a storehouse of minerals. Figure 5.9. The pie diagram shows the description of limestone state-wise share in percent 2003-2004. Andhra Pradesh contributes 16% of limestone, Madhya Pradesh contributes 15%, and also Rajasthan with 15%. Gujarat produces 11% of limestone in the country, whereas Tamil Nadu only 9%. Others contribute 34% of limestone in the country. Hazards of mining. Have you ever wondered about the efforts the miners make in making life comfortable for you? What are the impacts of mining on the health of the miners and the environment? The dust and noxious fumes inhaled by miners make them vulnerable to pulmonary diseases. The risk of collapsing mine roofs. Inundation and fires in coal mines are a constant threat to miners. The water sources in the region get contaminated due to mining. Dumping of waste and slurry leads to degradation of land, soil, and increase in stream and river pollution. Figure 5.10. There's a picture which depicts the air pollution due to the generation of dust in mining areas. Page 57. A collage from some news items is given, reporting the unsafe means of mining which causes damage to man and environment. From the text, stricter safety regulations and implementations of environmental laws are essential to prevent mining from becoming a killer industry. Conservation of minerals. We all appreciate the strong dependence of industry and agriculture upon mineral deposits and the substance manufactured from them. The total volume of workable mineral deposits is an insignificant fraction, that is, 1% of the Earth's crust. We are rapidly consuming mineral resources that are required millions of years to be created and concentrated. The geological processes of mineral formation are so slow that the rates of replenishment are infinitely small in comparison to the present rates of consumption. Mineral resources are, therefore, finite and non-renewable. Rich mineral deposits are our country's extremely valuable but short-lived possessions. Continued extraction of ores leads to increasing costs as mineral extraction comes from greater depths, along with decrease in quality. Page 58. A concerted effort has to be made in order to use our mineral resources in a planned and sustainable manner. Improved technologies need to be constantly evolved to allow use of low-grade ores at low costs. Recycling of metals, using scrap metals, and other substitutes are steps in conserving our mineral resources for the future. Dig a little deeper. Make a list of items where substitutes are being used instead of minerals. Where are these substitutes obtained from? Energy resources. Energy is required for all activities. It is needed to cook, to provide light and heat, to propel vehicles, and to drive machinery in industries. Energy can be generated from fuel minerals like coal, petroleum, natural gas, uranium, and from electricity. Energy resources can be classified as conventional and non-conventional sources. Conventional sources include firewood, cattle dung cake, coal, petroleum, natural gas, and electricity, that is, both hydel and thermal. Non-conventional sources include solar, wind, tidal, geothermal, biogas, and atomic energy. Firewood and cattle dung cake are most common in rural India. According to one estimate, more than 70% energy requirement in rural households is met by these two. Continuation of these is increasingly becoming difficult due to decreasing forest area. Moreover, using dung cake too is being discouraged because it consumes most valuable manure which could be used in agriculture. Conventional sources of energy. Coal. Coal. In India, coal is the most abundantly available fossil fuel. It provides a substantial part of the nation's energy needs. It is used for power generation, to supply energy to industry as well as for domestic needs. India is highly dependent on coal for meeting its commercial energy requirements. As you are already aware that coal is formed due to compression of plant material over millions of years. Coal, therefore, is found in a variety of forms depending on the degree of compression and the depth and time of burial. Decaying plants and swamps produce peat, which has a low carbon and high moisture contents and low heating capacity. Lignite is a low-grade brown coal, which is soft with high moisture content. The principal lignite reserves are in Neyveli in Tamil Nadu and are used for generation of electricity. Coal that has been buried deep and subjected to increased temperatures is bituminous coal. It is the most popular coal in commercial use. Metallurgical coal is high-grade bituminous coal which has a special value for smelting iron in blast furnace. Anthracite is the highest quality hard coal. Figure 5.11a gives us a view from inside of a coal mine. And figure 5.11b gives us a view from outside of a coal mine. In India, coal occurs in rock series of two main geological ages, namely Gondwana, a little over 200 million years in age, and in tertiary deposits, which are only about 55 million years old. The major resources of Gondwana coal, which are metallurgical coal, are located in Damodar Valley, that is in West Bengal, Jharkhand. Jharia, Raniganj, Bokaro are important coal fields. The Godavari, Mahanadi, Son and Varda valleys also contain coal deposits. Tertiary coals occur in the northeastern states of Meghalaya, Assam, Arunachal Pradesh and Nagaland. Remember, coal is a bulky material which loses weight on use as it is reduced to ash. Hence, heavy industries and thermal power stations are located on or near the coal fields. Page 59. The India map shows the conventional energy resources. Here in this map, they show the various coal fields spread over a larger areas of Madhya Pradesh, Maharashtra, parts of Andhra Pradesh, Chhattisgarh, Jharkhand, Odisha, West Bengal, and even Meghalaya and Assam. The coal mines are located in Korba, Singareni, Neyveli, Talcher, Jharia, Raniganj, and Singrauli. The oil fields are also located here in this map, where we see the offshore oil fields in Mumbai High and Basin, in Kalol in Gujarat, and Ankleshwar again in Gujarat. The HVJ pipeline also been shown here in this map, which joins many cities of Gujarat, Madhya Pradesh, and Uttar Pradesh mainly. The Hazira Vijaypur Jagdishpur natural gas pipeline runs through the major industrial parts of this country. Some of the oil fields are also confined in northeastern part of India. One is the oldest oil field of our country, that is Digboi in Assam. Also Sibsagar and Naharkatia. The major natural gas reserves are shaded in grey in this map. The continental shelf of southeast coast of India, also the western continental shelf of India has the natural gas reserves. The natural gas reserve is also found in Gujarat, that is in Kalol and Vadodara region. A patch is also shown in the western Rajasthan region and in a northeastern state. Page 60. Petroleum. Petroleum or mineral oil is the next major energy source in India after coal. It provides fuel for heat and lighting, lubricants for machinery, and raw materials for a number of manufacturing industries. Petroleum refineries act as a nodal industry for synthetic textile, fertilizer, and numerous chemical industries. Most of the petroleum occurrences in India are associated with anticlines and fault traps in the rock formations of the Tertiary age. In regions of folding, anticlines or dooms, it occur where oil is trapped in the crest of the upfold. The oil-bearing layer is a porous limestone or sandstone through which oil may flow. The oil is prevented from rising or sinking by intervening non-porous layers. Petroleum is also found in fault traps between porous and non-porous rocks. Gas, being lighter, usually occurs above the oil. About 63% of India's petroleum production is from Mumbai High, 18% from Gujarat, and 16% from Assam. From the map, locate the three major offshore fields of Western India. Ankleshwar is the most important field of Gujarat. Assam is the oldest oil-producing state of India. Digboi, Naharkatia, and Moran Hugrijan are the important oil fields in the state. Natural gas. Natural gas is an important clean energy resource found in association with or without petroleum. It is used as a source of energy as well as industrial raw material in the petrochemical industry. Natural gas is considered an environment-friendly fuel because of low carbon dioxide emission and is therefore the fuel for the present century. Large reserves of natural gas have been discovered in the Krishna-Godavari basin. Along the west coast, the reserves of Mumbai High and allied fields are supplemented by finds in the Gulf of Cambay. Andaman and Nicobar Islands are also important areas having large reserves of natural gas. The 1,700-kilometer long Hazira Vijaypur Jagdishpur cross-country gas pipeline links Mumbai High and Basin with the fertilizer, power and industrial complexes in western and northern India. This artery has provided an impetus to India's gas production. The power and fertilizer industries are the key users of natural gas. Use of compressed natural gas, that is CNG, for vehicles to replace liquid fuels is gaining wide popularity in the country. Electricity. Electricity has such a wide range of applications in today's world that its per capita consumption is considered as an index of development. Electricity is generated mainly in two ways: by running water which drives hydro turbines to generate hydroelectricity, and by burning other fuels such as coal, petroleum and natural gas to drive turbines to produce thermal power. Once generated, the electricity is exactly the same. Hydroelectricity is generated by fast-flowing water, which is a renewable resource. India has a number of multi-purpose projects like the Bhakra Nangal, Damodar Valley Corporation and Kopali Hydel Project, etc., producing hydroelectric power. Thermal electricity is generated by using coal, petroleum and natural gas. The thermal power stations use non-renewable fossil fuels for generating electricity. There are over 310 thermal power plants in India. Activity. Name some river valley projects and write the names of the dams built on these rivers. From the map, identify a thermal power station in your state and also name the fuel that is used there. Page 61. An India map is given which shows the various power plants all over the country. A few nuclear power plants are given here, which are located in Kakrapara, Gujarat, Tarapur, Maharashtra, Kega in Andhra Pradesh, Kalapakkam, Tamil Nadu, and Narora in Uttar Pradesh. Kega in Karnataka. There are many thermal power stations located in this map of India. Some of them are Tuticorin, Neyveli and Ennore in Tamil Nadu, Talcher in Odisha, Uran, Nashik, Parli, Bhusawal in Maharashtra, Panki and Paricha in Uttar Pradesh, Barauni in Bihar, Delhi, Faridabad, Bongaigaon in Assam, Singrauli, Amarkantak, Satpura in Madhya Pradesh, Sabarmati, Gandhinagar, Ahmedabad in Gujarat. Page 62. Non-conventional sources of energy. The growing consumption of energy has resulted in the country becoming increasingly dependent on fossil fuels such as coal, oil and gas. Rising prices of oil and gas and their potential shortages have raised uncertainties about the security of energy supply in future, which in turn has serious repercussions on the growth of the national economy. Moreover, increasing use of fossil fuels also causes serious environmental problems. Hence, there is a pressing need to use renewable energy sources like solar energy, wind, tide, biomass, and energy from waste material. These are called non-conventional energy sources. India is blessed with an abundance of sunlight, water, wind, and biomass. It has the largest programs for the development of these renewable energy resources. Nuclear or atomic energy is obtained by altering the structure of atoms. When such an alteration is made, much energy is released in the form of heat, and this is used to generate electric power. Uranium and thorium, which are available in Jharkhand and the Aravalli ranges of Rajasthan, are used for generating atomic and nuclear power. The monazite sands of Kerala is also rich in thorium. Locate the 6 nuclear power stations and find out the state in which they are located. Solar energy. India is a tropical country. It has enormous possibilities of tapping solar energy. Photovoltaic technology converts sunlight directly into electricity. Solar energy is fast becoming popular in rural and remote areas. The largest solar plant of India is located at Madhapur near Bhuj, where solar energy is used to sterilize milk cans. It is expected that use of solar energy will be able to minimize the dependence of rural households on firewood and dung cakes, which in turn will contribute to environmental conservation and adequate supply of manure in agriculture. Figure 5.12. There's a picture which shows the solar-operated electronic milk testing equipment. Wind power. India now ranks as a wind superpower in the world. The largest wind farm cluster is located in Tamil Nadu, from Nagarkoil to Madurai. Apart from these, Andhra Pradesh, Karnataka, Gujarat, Kerala, Maharashtra and Lakshadweep have important wind farms. Nagarkoil and Jaisalmer are well known for effective use of wind energy in the country. Figure 5.13. The picture shows the windmills in Nagarkoil. Biogas. Shrubs, farm waste, animal and human waste are used to produce biogas for domestic consumption in rural areas. Decomposition of organic matter yields gas, which has higher thermal efficiency in comparison to kerosene, dung cake and charcoal. Biogas plants are set up at municipal, cooperative and individual levels. The plants using cattle dung are known as gobar gas plants in rural India. These provide twin benefits to the farmer in the form of energy and improved quality of manure. Biogas is by far the most efficient use of cattle dung. It improves the quality of manure and also prevents the loss of trees and manure due to burning of fuel wood and cow dung cakes. Figure 5.14. A picture which shows a biogas plant. Page 63. Tidal energy. Oceanic tides can be used to generate electricity. Floodgate dams are built across inlets. During high tide, water flows into the inlet and gets trapped when the gate is closed. After the tide falls outside the floodgate, the water retained by the floodgate flows back to the sea via a pipe that carries it through a power-generating turbine. In India, the Gulf of Kutch provides ideal conditions for utilizing tidal energy. A 900 megawatt tidal energy power plant is set up here by the National Hydropower Corporation. Geothermal energy. Geothermal energy refers to the heat and electricity produced by using the heat from the interior of the earth. Geothermal energy exists because the earth grows progressively hotter with the increasing depth. Where the geothermal gradient is high, high temperatures are found at shallow depths. Groundwater in such areas absorbs heat from the rocks and becomes hot. It is so hot that when it rises to the Earth's surface, it turns into steam. This steam is used to drive turbines and generate electricity. There are several hundred hot springs in India, which could be used to generate electricity. 2 experimental projects have been set up in India to harness geothermal energy. One is located in the Parvati Valley near Manikaran in Himachal Pradesh, and the other is located in the Puga Valley, Ladakh. Conservation of energy resources. Energy is a basic requirement for economic development. Every sector of the national economy, agriculture, industry, transport, commercial and domestic, needs input of energy. The economic development plans implemented since independence necessarily required increasing amounts of energy to remain operational. As a result, consumption of energy in all forms has been steadily rising all over the country. In this background, there is an urgent need to develop a sustainable path of energy development. Promotion of energy conservation and increased use of renewable energy sources are the twin planks of sustainable energy. India is presently one of the least energy efficient countries in the world. We have to adopt a cautious approach for the judicious use of our limited energy resources. For example, as concerned citizens, we can do our bit by using public transport systems instead of individual vehicles, switching off electricity when not in use, using power-saving devices, and using non-conventional sources of energy. After all, energy saved is energy produced. Page 64. Exercises. Question 1. Multiple choice question. Question 1 of 1. Which of the following minerals is formed by decomposition of rocks, leaving a residual mass of weathered material? The 4 choices given here are A. Coal, B. Bauxite, C. Gold, and D. Zinc. Question 2 of 1. Koderma in Jharkhand is the leading producer of which one of the following minerals? The choices are A. Bauxite, B. Mica, C. Iron ore, and D. Copper. 3 of 1. Minerals are deposited and accumulated in the stratas of which of the following rocks? A. Sedimentary rocks, B. Metamorphic rocks, C. Igneous rocks, or D. None of the above. 4 of 1. Which of the following minerals is contained in the monazite sand? A. Oil, B. Uranium, C. Thorium, or D. Coal? Question 2. Answer the following questions in about 30 words. 1 of 2. Distinguish between the following in not more than 30 words. A. Ferrous and non-ferrous minerals. B. Conventional and non-conventional source of energy. 2 of 2. What is a mineral? 3 of 2. How are minerals formed in igneous and metamorphic rocks? 4 of 2. Why do we need to conserve mineral resources? Question 3. Answer the following questions in about 120 words. 1 of 3. Describe the distribution of coal in India. 2 of 3. Why do you think that solar energy has a bright future in India? Activity. The crossword given here has the name of minerals hidden in the graticules, spread over 16 rows and 13 columns, across and down. The clue to solve the crossword is also given. Across. First, a ferrous mineral. Second, raw material for cement industry. Third, finest iron ore with magnetic properties. Fourth, highest quality hard coal. Fifth, aluminium is obtained from this ore. Sixth, Khetri mines are famous for this mineral. Seventh, formed due to evaporation. Down. First, found in placer deposits. Second, iron ore mined in Bailadila. Third, indispensable for electrical industry. Fourth, geological age of coal found in northeast India. Fifth, formed in veins and lodes. You were just listening to Chapter 5, Minerals and Energy Resources, read by Shiba Mal. Recorded by Shanu Muqsim. Production assistance Vimlesh Chaudhary, and produced by Ajit Horo. This audio chapter is brought to you by CIET NCERT, New Delhi.